Okay, ready for this? We're going deep on the Parker Solar Probe.
Ooh, that's a good one.
This thing is flying closer to the sun than anything we've ever sent up before.
It's incredible
Seriously, we're talking about getting closer to the sun.
than ever before.
We're going to be looking at excerpts from an article about this mission, and let me tell you, it's mind-blowing.
I can imagine.
So, what makes this mission so important? Well, for starters, scientists are hoping to unlock some of the sun's biggest secrets.
Some of the mysteries that have plagued us for a long time.
Exactly. And we're going to be talking about things like the extreme temperatures that the probe has to withstand, the crazy speeds it travels at, and this weird thing about the sun's corona that's just, well, it's puzzling, to say the least.
It's one of the biggest mysteries in solar science.
For sure. So let's dive right in, shall we?
Let's do it.
Okay, so the Parker Solar Probe is on a mission to, as we said, get closer to the sun than any other spacecraft.
That's right.
And we're talking seriously close, right?
Closer than we ever thought possible.
How close are we talking exactly?
At its closest, the probe will be a mere 3.8 million miles from the sun's surface.
3.8 million miles. That still sounds pretty far.
It does, but to put that in perspective, imagine the sun and Earth were just a meter apart.
Okay, I'm picturing it.
The probe would only be 4 centimeters away from the sun.
4 centimeters. That's like right there.
Almost touching it.
So it's not just a daring mission. It's practically a solar handshake.
Yeah.
But that close to the sun, there have got to be some pretty intense challenges, right?
Oh, absolutely. The probe is facing an incredibly extreme environment.
Like what?
Well, for one, the temperatures can reach 1,400 degrees Celsius.
Whoa, 1,400 degrees.
That's hot enough to melt most metals.
No kidding. And I'm guessing there's intense radiation, too.
Absolutely, the radiation levels are off the charts.
It's mind-boggling that we can even design a spacecraft to withstand that.
It really is a testament to human ingenuity.
So how does the probe survive in such a brutal environment?
Well, the key is the heat shield. It's a 4.5-inch thick carbon composite shield.
Wow, 4.5 inches thick. That's got to be one serious shield.
It is. It's designed to absorb and deflect the intense heat and radiation.
So basically a high-tech umbrella for one of the hottest places imaginable.
You could see that?
But let's not forget about the speed. This thing is moving at some crazy velocity, right?
Oh, yeah. It's not just fast. It's hurtling through space.
Hurtling, that's a good word for it.
At a mind-blowing 430,000 miles per hour.
430,000 miles per hour. Hold on, let me try and wrap my head around that.
To put that in perspective, that's like traveling from London to New York in under 30 seconds.
London to New York in under 30 seconds. I can't even get to the coffee shop that fast.
It's hard to imagine, isn't it?
But I'm guessing there's got to be more to this mission than just breaking speed records, right?
You're right. The real goal here is to unravel some of the sun's biggest mysteries.
Like what?
Well, one of the most perplexing is the temperature of the corona.
Ah, the corona. Now remind me, that's the sun's outer atmosphere, right?
Exactly, the one we see during a total solar eclipse, that sort of ethereal halo around the sun.
Right, I remember.
And here's the thing, the corona is millions of degrees hotter than the sun's surface.
Wait, millions of degrees hotter? But how is that possible?
That's the big question.
Isn't the surface of the sun like 6,000 degrees Celsius?
That's right, about 6,000 degrees. But the corona, further away from the core, is somehow millions of degrees hotter.
That seems backwards.
It does. It's like a campfire where the flames are hotter than the burning logs.
Yeah, I don't get it. How can something further away from the heat source be hotter? What do scientists think is going on?
There are several theories floating around. One idea is this process called magnetic reconnection.
Magnetic reconnection?
It's where magnetic field lines twist and snap.
Ooh, that sounds intense.
And when they do that, it releases a tremendous amount of energy.
And then that energy heats the corona.
That's the idea. Another theory points to Kelvin waves.
Kelvin waves, what are those?
They're magnetic waves that travel along the sun's magnetic field lines, carrying energy from the interior out to the corona.
Like little energy surfers riding the magnetic waves.
Exactly. And then there's this other idea about nanoflares.
Nanoflares. Okay, this is getting interesting.
These are tiny bursts of energy that happen all the time throughout the corona.
Like little solar sparklers.
Kind of, and collectively they might be contributing to the corona's high temperature.
So we've got these different theories, but which one is right?
That's what the Parker Solar Probe is trying to figure out by flying directly into the corona and gathering data.
Wow. Right into the heart of the mystery.
Exactly. It's giving us a front row seat to try and solve this puzzle.
So it's like we're watching a cosmic fireworks display. but trying to figure out the physics behind it at the same time.
That's a great analogy.
But why is it so important to understand the corona's temperature, besides just, solving a scientific puzzle?
Well, it's not just about curiosity.
What else is it about, then?
Understanding the corona is key to understanding something called solar wind.
Solar wind. Okay, now you have to explain that one.
Imagine a constant stream of charged particles flowing out from the sun's corona.
Stream of particles.
Yep, and it's a powerful force.
Powerful in what way?
It can have a big impact on our planet, believe it or not.
These particles reach Earth. Wait, what happens when they do?
Sometimes they interact with Earth's magnetic field in really fascinating ways.
Give me an example.
Ever seen the Northern Lights?
You mean the Aurora Borealis?
Click one.
Of course, who hasn't? It's on my bucket list.
They're caused by solar wind interacting with Earth's magnetic field.
No way. So that incredible light show is all thanks to the sun.
In a way, yes.
That's amazing. But it sounds like there might be a downside too.
There can be. Sometimes intense solar wind can disrupt our power grids, damage satellites, even interfere with communication systems.
So it's not all pretty lights and auroras then?
Not always. It's a powerful force that we need to understand better.
So understanding solar wind is important for practical reasons, not just scientific curiosity.
Exactly.
Like for protecting our technology and infrastructure.
Exactly. The Parker Solar Probe is helping us do just that.
By studying the solar wind up close.
Yes, it's giving us a better understanding of how it works, which can help us predict and prepare for these events.
So, if we know a solar storm is coming, we can take steps to protect our power grids and satellites.
Precisely.
Wow. So this tiny probe is not just helping us unlock the mysteries of the sun, it's also helping to protect us here on Earth.
It is. It's a remarkable mission.
When you put it that way, it makes you realize just how important the sun is to us.
It's the heart of our solar system.
Without it, we wouldn't be here.
Exactly. It provides the light and warmth that make life on Earth possible.
But it's also this powerful, sometimes unpredictable force.
It is, and the Parker Solar Probe is helping us understand both sides of that coin.
The life-giving side and the potentially destructive side.
Exactly.
It's incredible to think about.
It really is.
It's like we're reading a thrilling detective novel.
A cosmic detective novel.
Yeah, but instead of a crime scene, we're investigating the sun itself.
It's a great way to put it.
And the clues are all these fascinating phenomena like the corona's temperature, solar wind, and who knows what else we'll discover.
The probe is still gathering data. There's so much more to learn.
It's exciting to think about what other secrets the Parker Solar Probe might reveal.
It's a mission that's full of potential.
And it makes you realize just how much we still don't know about the universe, even about our own star.
There's always more to discover.
And that's what makes science so amazing.
It's a never-ending journey of exploration.
I love it. But for now, I think we've covered a lot of ground in this first part of our deep dive. What do you say we take a break and come back to explore even more about the Parker Solar Probe's findings?
Sounds like a plan.
All right, we'll be back soon with more insights into this incredible mission, so stay tuned.
I can't wait. Welcome back. Before the break, we were talking about how the Parker Solar Probe is giving us a new perspective on the sun and how that impacts us here on Earth.
Yeah, it's pretty mind-blowing to think about this little probe, flying through space and braving that insane heat. Also, we can learn more about our star.
It really is a marvel of engineering.
Absolutely. A real testament to human innovation and collaboration.
And speaking of innovation,
yeah.
One thing that really struck me about the Parker Solar Probe is its autonomous navigation system.
Oh, yeah. The fact that it can basically think for itself, that's going to be super important, right? Especially with the, extreme conditions and how far away it is.
Exactly. It would be impossible for humans to control the probe in real time.
So how does it work? Does it have some kind of AI on board?
You could say that. It has a sophisticated system of sensors and computers.
Like a mini brain.
Sort of, yeah. It's constantly monitoring its position, speed, trajectory.
And making adjustments to stay on course.
Exactly, and to avoid any potential hazards.
I mean, talk about a high-pressure job. What kind of hazards are we talking about here?
Well, the sun itself is obviously the biggest hazard, right?
Yeah, for sure.
It needs to stay at a precise distance to get the data without, getting fried by the heat and radiation.
Yeah, no kidding.
But there are other things too, like solar flares.
Solar flares?
And coronal mass ejections. Those are sudden bursts of energy and particles that can be dangerous.
So it's like a cosmic obstacle course out there.
You could say that. And it's doing a remarkable job navigating it all.
It's amazing to think about this little robot out there making its own decisions as it flies closer and closer to the sun.
It's pretty incredible.
This autonomous navigation technology, I bet that's going to be crucial for future missions too, right?
Absolutely, especially as we start exploring deeper into space.
It's exciting to think about what the future holds for space exploration.
It really is.
But for now, I'm curious, what has the Parker Solar Probe discovered so far? What are some of the highlights?
Well, one of the most significant discoveries has been the detection of those switchbacks in the solar wind.
Ah, yes, the switchbacks. We talked about those earlier, the sudden reversals in the magnetic field.
Right.
Honestly, I'm still a little fuzzy on why they're so important.
They're important because they challenge our understanding of the solar wind.
Is also.
We used to think of it as this, steady stream of particles flowing out from the sun.
Yeah, okay.
But these switchbacks are showing us that it's much more dynamic, much more complex.
So these switchbacks are like shaking things up.
Exactly. And that has implications for how we predict space weather events here on Earth.
Space weather.
Yeah, things like solar storms that can disrupt our satellites and power grids.
Oh, right, right.
Understanding the solar wind, including these switchbacks, can help us forecast these events more accurately.
So the Parker Solar Probe is kind of like a solar detective, gathering clues to help us solve these mysteries.
I like that analogy.
And the more data we gather, the more we can understand about the sun and its impact on us.
Exactly. It's all about piecing together the puzzle.
So we've got the heat shield, the incredible speed, the autonomous navigation, the discoveries about switchbacks, and the corona's temperature. What else? What's next?
Well, there's one more crucial element to the Parker Solar Probe's mission. It's trajectory.
Trajectory, you mean how it's flying towards the sun?
Not quite. It's not just flying straight towards the sun. It's actually using gravity assists from Venus.
Venus? Hold on, how does that work?
It's a really clever technique, actually.
I'm all ears.
It takes advantage of something called a gravity assist. Basically, the probe uses Venus's gravity to alter its speed and trajectory.
I'm trying to visualize this. So, as it gets close to Venus, it gets pulled in by the planet's gravity.
Right, and that causes it to speed up.
So it's like a cosmic slingshot.
Exactly. And then, as it swings around Venus, it gets flung back out into space.
But at a different angle.
Exactly, at an angle that brings it closer to the sun.
Wow, that's incredible. So it's not just about brute force, it's about using the laws of physics to our advantage.
Precisely. It's a beautiful example of celestial mechanics in action.
So the probe does this multiple times. Like, it keeps flying past Venus to get closer and closer to the sun.
Exactly. The plan is for it to perform 7 Venus flybys over the course of its mission.
Wow, that's amazing.
Yeah.
It's like a carefully choreographed dance between the probe and Venus.
It is. It's a testament to the brilliance of the engineers and scientists who designed this mission.
What's really cool is that this approach means the probe doesn't need to carry a ton of fuel, right?
Right. It's a very efficient way to get closer to the sun.
It's amazing how much thought and planning goes into these missions.
It really is. It's a combination of, daring, innovation, precision.
All working together to unlock the secrets of the sun.
Exactly.
It's incredibly inspiring, It makes you realize what we're capable of when we set our minds to something.
Absolutely. The Parker Solar Probe is pushing the boundaries of what we thought was possible.
And speaking of pushing boundaries, I wanted to circle back to something we touched on earlier. The potential for this mission to help us understand the origins of life itself.
Ah, yes. That's a fascinating connection. Remind me, how does studying the sun relate to the origins of life?
Well, it all comes down to the sun's role in creating the conditions for life to exist, not just on Earth, but potentially elsewhere too.
Right. The sun provides the energy that drives life, but it can also be pretty harsh with all that radiation and solar wind.
Exactly. The Parker Solar Probe is helping us understand this balance.
This delicate dance between the life-giving and potentially destructive aspects of the sun.
Exactly. By studying the sun's activity, we can learn how it has interacted with Earth's atmosphere over time.
And how it might have influenced the development of life.
Precisely. We can study things like the evolution of Earth's magnetic field, which protects us from a lot of that harmful radiation.
So we're using the sun as a model to understand the conditions needed for life to arise.
Exactly. It's like using the sun as a cosmic blueprint for life.
It's amazing to think that we can use what we learn about our own star to search for life on other planets.
It is. And the Parker Solar Probe is giving us the data we need to do just that.
It's really groundbreaking stuff.
It is. It just shows you space exploration isn't just about discovering new worlds. It's also about understanding our own place in the universe.
And understanding the fundamental processes that make life possible.
Absolutely. What really strikes me about this mission is the incredible level of collaboration involved.
Oh yeah, the international aspect.
Exactly. This isn't just a NASA mission, it's a global effort. Scientists and engineers from all over the world are working together to make this happen.
It's a testament to the power of international cooperation in science.
It really is. And it's not just about the scientists either. The Parker Solar Probe is captivating people all over the world. It's inspiring, you know.
Definitely. It sparks that sense of wonder and curiosity in everyone.
It's a reminder that we're all connected, we're all part of this incredible cosmic journey.
I love that. It's about pushing the boundaries of human knowledge together.
Okay, before we get too philosophical, there's one last thing I wanted to touch on. The potential for the Parker Solar Probe to reveal secrets about the very nature of the universe itself.
Okay, now that's a big one. How does studying the sun shed light on the workings of the entire universe?
Well, it comes down to the fact that the sun is a giant laboratory for studying something called plasma physics.
Plasma physics. Now, remind me what that is again?
Plasma is often called the fourth state of matter. You know, you've got solids, liquids, gases, and then there's plasma, which is essentially superheated ionized gas.
So it's like a gas, but with an electric charge.
Exactly. And it turns out that plasma is the most common state of matter in the universe.
Wow, I didn't realize that.
So by studying the sun, which is basically a giant ball of plasma,
Yeah.
we can learn about the fundamental properties of this incredibly important state of matter.
And apply that knowledge to understand other phenomena in the universe.
Precisely. The Parker Solar Probe is giving us an up-close look at how plasma behaves in extreme environments.
Like the sun's corona.
Exactly.
Yeah.
And that can help us understand things like star formation, the behavior of galaxies.
So it's like we're studying the small to understand the big.
Exactly. The Parker Solar Probe is giving us that microscopic view, which we can then use to understand the larger workings of the cosmos.
It's amazing how everything is connected.
It really is. You know, this mission is about so much more than just the sun. It's about the very building blocks of the universe.
It's about our place in the cosmos.
And about pushing the boundaries of human knowledge.
It's truly inspiring.
It is. It makes you realize how much there is still out there to discover.
And how much potential we have to understand the universe.
Absolutely. Okay, I know we could talk about this forever, but I think it's time to shift gears a bit.
Sounds good. What are you thinking?
Let's take a step back from all the details and focus on the bigger picture, you know.
The implications of this mission, what it means for our understanding of the universe, and our place in it.
Exactly. Ready to get a little philosophical?
Absolutely. Let's do it.
Wow. I don't know about you, but this whole deep dive has left me feeling pretty amazed.
Me too. The Parker Solar Probe is such a fantastic example of what we can achieve when we combine our curiosity with, well, really impressive engineering.
It's true. I mean, before we started talking about this, I had this, I don't know, this sort of basic idea of the sun, you know, big, bright, hot.
The thing that keeps us warm.
Yeah, exactly. But now I see it as this like dynamic and kind of mysterious force.
Powerful too.
Oh, yeah, definitely powerful. It's a little humbling, honestly, to realize how much this giant ball of plasma affects our lives here on Earth.
It's one of the things that makes studying the sun so fascinating, you know? This constant balance between its beauty, its power, the way it gives us life, but can also be kind of dangerous.
It's true, and the Parker Solar Probe is helping us understand that balance in such a new way.
In ways we never thought possible before.
And it's not just about the science itself, it's about, like, the human element too, right? Pushing the limits of what we can do, sending a spacecraft to basically touch the sun.
It's a pretty bold move.
It's incredible, a true feat of engineering.
And it captures that spirit of exploration, that drive to challenge what we think we know and search for answers.
And not just scientists, it's inspiring people all over the world.
Absolutely. Everyone loves a good space mission.
It's true. And it shows how important international collaboration is too.
Right. This isn't just one country's mission, it's a global effort.
It really highlights how much we can achieve when we work together.
And it's a reminder that science transcends borders.
So well said. You know, I think one of the biggest takeaways from this whole deep dive is that the Parker Solar Probe is more than just about studying the sun.
It's about so much more.
It's about pushing boundaries, it's about collaboration, it's about that endless human curiosity that drives us to explore.
And it's about understanding our place in the universe.
Exactly, and I think that's a pretty good place to wrap up our deep dive into the Parker Solar Probe.
I agree. It's been a fantastic journey.
It has. And I hope our listeners have enjoyed exploring this incredible mission with us.
I've certainly enjoyed talking about it.
Me too. So until next time, everyone, keep looking up and keep exploring.
There's a whole universe out there waiting to be discovered.